Hello? Oh, I'm on. Hey. Hi, Sydney. Can I just call you all Sydney? Would that be all right? So welcome. My name's Michelle. We're here for an hour, right? And I'm thinking I'm going to pack 2 platforms and a quick review in an hour. Are you ready for that? It's okay? Good? All right. So my name's Michele Bustamante. I'm here from San Diego, and I'm part of a company called Alliance. So we do architecture consulting and many other things. But of late, I've actually been building a Docker and ServiceFabric and microservices practice. So we've actually been playing a lot with both of the platforms, and just finished a hackathon on ServiceFabric, which was really fun. And I think it'll be great to just have a little bit of an open dialogue while I show you some demos and talk a little bit about, I guess, the sentiment and the feeling that I get with the teams that we've been working with the various platforms, and a few of them, on Amazon, on Azure. So it's a fun space, and it's a very vibrant space right now. Who loves microservices? Okay, you're not sure yet. That's all right. It's a buzzword, right? Just like SOA from way back. So yes, I'm on fire today. Let's go. So Docker and ServiceFabric, ready to go. Let's talk about microservices, the too long didn't read version, because there's plenty of those sessions here, but just a quick digest. Hello World, 1992. Who remembers that? Me neither. Okay. Hello World today. Yes, that's about it, right? Who can build an app today without dealing with mobile, responsive web, devices on the front, APIs on the back, maybe some API management in the middle, because that's the new thing as well. Everything's got a back end. We've got services and tiers and APIs and web apps. So it's complicated, right? I mean, I remember being able to build one thing. I kind of remember being able to build one thing, executable, and run away for lunch and come back and hope it compiled. And now it's like all these things everywhere. But that in itself is not microservices, right? This is just, building apps today has usually a lot of facets, and you have different team members that are experts in the various areas, right? Not everybody does mobile. Not everybody does back-end and security and all the things. But how did we get here? So we started with monolith, which in the old days was one big thing, like an executable. Today's monolith is really just an app that's not well decoupled. And when we started with the big monolith back in the day, the decoupling started in a different way, right? We started with trying to break down data and scale it in the back end. So we had the client and the server, right? And then eventually that moved into distributed components like, we had Corba, we had DCOM. And the idea behind those were I'd be able to distribute components and scale somehow. And then eventually we realized that didn't scale either because of connections, right? And so then we moved to the interoperable version of that, which would have been SOA, that old buzzword. And service-oriented architecture's promise was to decouple, but also help you with isolation and segmentation of business functions, right? So almost microservice-like, right, that perspective. There's a lot of synergies between that time and the things we talked about and the things that we're talking about today. It's just there's more to it now, right, and more pieces. So service-oriented architecture was another sense of decoupling. And then we moved to let's distribute things across the cloud and build PaaS and services that we can leverage in our ecosystem, right? So now we're stitching together things from other people, from us, from our development team, from third parties, and again, PaaS as well. So, just a continuation of the decoupling, of the reuse, and so on. And now microservices. So, the point of microservices, yet another layer of decoupling, only hopefully maybe done better. If we're going to embrace this approach, we have to embrace a couple of other things that will make it successful, like the whole DevOps story, right? Without automation and DevOps, you probably simply can't be successful with microservices, because now there's just, and you might argue, well, we should be doing that anyways, right? So in a way, maybe it's forcing us to better practices, forcing us to think about better practices, because now we're decoupling apps to a smaller granularity, and therefore having to have ways to manage that better. Make sense? So decoupling, it's so hot right now. That is sort of where we're heading. And the idea is we take this picture and turn it into smaller units of functionality that we can isolate from one another, that we can have a separate life cycle of development, deployment, management, update. And the real goal behind all of this really is not the developer and not the technology people, it's the business. Because the business wants to say, I want new features here and here. And they're tired of waiting for those new features because we're afraid. How many people are ever afraid to update the apps they work on today because of regression testing? Okay, right, because of course you have regression tests across the entire application and every moving part to where you're not afraid to do that, right? So, you know, the promise of this is hopefully that sense of isolation if we do it right. There is that if, right? Like you have to do it right. So put another way, I can build a very badly designed monolith and I can build a very badly designed microservices architecture as well, which means I still have to design. I still have to take a step back and try to think through, what am I actually doing here, yes? Okay, so that's my TLDR on that front. And then talking design, one of the things I like to talk about is how do we approach thinking about design before we look at the platform? So I've had to go into some customers where they don't know yet if they want to go with Docker or ServiceFabric, literally. Or maybe they're going with Docker, but they don't know yet if they're going to go with Docker on Amazon or Azure. Or they don't know yet if they want to use Docker Data Center or Mesos DCOS, or go with a raw Docker deployment where they pick and choose the tooling themselves and manage it themselves using Swarm and deciding behind the scenes whether they want to use Console or whether they want to use Zookeeper, and the list goes on, right? So there are some choices, and that's a good thing and a bad thing sometimes. And so before you even get there, you can actually take a step back and just look at your app, right? How do I break down an app into parts? How do I break it into these, you know, separate functional services, these segments of functionality that can have their own life cycle and update cycle? Now, I know what you're thinking, maybe, that of course, how can I possibly know that these can have their own lifetime or life cycle and update cycle? And the answer is, well, you might not get it perfect the first time, but you can take a shot at it. So I always suggest take a shot at it first. Take a look at the services across your app. So this is an order system. It's got, you know, the typical things that you have. You have customers, you have orders, you have shopping carts, you have products and fulfillment on the back end. These are separate functions that might have different behavior, different workflows, different interactions with the back end, the corporation and or the customer. And then maybe there's some reuse services at the back related to notifications and emails and whatnot. But at the end of the day, they have their own functionality that they can own, which means they might get updated separately. You might have different teams on them. Suggestion services, payment services, accounts, and managing the users and the accounts and the permissions. So the list goes on. This is just an example. If you can try to break that up and then look at the data and say, okay, well, which of these has isolated state? What do these services own? What are the actual, you know, back end that each of these services could say, this is I am the primary owner of this data model, if you will. Now, that doesn't mean there aren't the concept of relations, because we all know when you update an order, you might have to relate it to a customer. And likewise, when I edit my customer, you know, I want to maybe go and look at their orders or something like that. So there are the need to have these query patterns through the system that might somehow have the need to pull together data. And I always suggest don't try to tackle that problem first when you're looking at the microservices architecture. Tackle that after you've looked at, these are logical segments of my application. And then let's think about, well, what are the potential relations? And we can't really fully answer that question until you actually know the query patterns through the system. You need to understand, I'm going to need to get this data this way to understand whether or not you could go get that from 2 collections or 2 services, or whether or not it could be eventually consistent on the back end where you have a collection of the aggregate data that you can query in different ad hoc ways while still correlating, you know, the data primarily with the service owner. So there's interesting choices there, which is why I say try not to solve that problem first. Now, this is not really a talk about how do I design all of my microservices. Obviously, we could talk about that in lots of different ways. But I just wanted to give a taste of that because what I find is that sometimes you can leverage a piece of a platform to solve some of these problems. And I think that's part of what I want to get to. So thinking about the services and the breakdown and thinking about the fact that some of that data model might just be a cache, which means maybe it's a clustered cache or Redis or something, right? Is that going to be a container? Or is it going to be a service in Amazon or in Azure? I don't know. That's where we start tying in the platform and making decisions that we leverage pieces of our platform. So that's why I say, think of it this way first, and then apply the platform and the tools you might be able to leverage. Another thing might be, there are no data at the back end in terms of, maybe I'm leveraging an aggregate data model way back there that's not owned by the service, but I'm talking to an analytics engine or something like that, doing some machine learning and so on. So again, you're just trying to isolate, what of these services have state, what of these services have function and maybe leverage other PaaS functions, what of these are just executable functions like email. It's just an email service. It doesn't have to hold a state. It's just going to do some stuff. So get that out there, and then maybe think about what the front end looks like. Now, some people talk about microservices in a way where even the UI part is owned by the service, meaning we might emit some of the representation, and that's something that you can decide upon. So I usually try not to go there right away because I think that adds complexity to your development and lifecycle of development. It's a lot easier to think about your front end as these things that maybe I will compartmentalize enough that they have their own update lifecycle, like subdomains across the system, but at the same time not necessarily worry about containerizing them right away. So that's a choice too. It's a style. It depends on the team and what you're accustomed to, what you're ready to do. Make sense? So there's just an idea of a picture. Moving along, now we talk about platforms, yeah? So Docker. Obviously, Docker is somewhat of a poster child of the microservices world, and it's a really nice platform to work with. It's lightweight. It feels good for developers. It feels good for DevOps. There are some things we have to consider once we get past the "isn't this awesome?" But luckily, there are answers to those considerations. So I kind of want to just start with the simple, parts, which is, the first thing we think about when we think about containerization is how lightweight it is, right? So when we deal with virtualization, we usually have the guest OS. This is the classic discussion. And when we deal with containers, we're talking about very lightweight binaries sitting on top of, the VM to where I can actually have density beyond what I would with the virtualization stack. So example would be 33% of CPU being used here, or I/O, and when you look over at the container side, it's 2%, That's just one number. It depends on your app, but there have been some folks that have published stats of their real deployments when they moved from virtualization to containerization, and they're real stats. So there's nothing to argue. It's fast, it's light, it gives you more server density. We have to talk about what the meaning of server density is, though, and how we achieve it successfully, okay? So hold that thought. And the other promise of this, of course, is the idea that whatever I build in a container, the image that is the base of the container is immutable, which means if it works on my machine, it's going to work when I publish it to the development environment, to the UAT environment, and to prod. And we love that, right? Because now I actually have predictability. So one of the things I've seen in terms of using Docker, I've had companies that are just small companies that are startups, and it's one guy. And it's nice for him to be able to know that he can build and test and run and build these containers that maybe he's not even doing clustered operations with Swarm. It's just there's a couple of machines load balanced, and we only have one instance of each container on each box, but he can manage that. And it's manageable, and it can work on his machine, and he can deploy it and link the containers, and it still works in the cloud, right? So there's something nice and lightweight and agile about that. Very nice. And then, of course, when we get into production distributed environments, we have to deal with things like, well, how do I really achieve the dynamic deployments with load balancing and density across the machines? So I'm going to get to that in a minute. Okay, so let's talk about just Docker Pure first. How many people already played with it? Yeah, okay. So then, you'll know all this stuff, basically. Let's see if I can, so let's go to which of my environments. It looks like, actually, I have a working internet. I've had a couple of interesting things going on there this week, but seems like it's all good. Okay. So I'm going to just go and take a look at quick couple of demos. And I'm going to start with just Docker basics, just for the sake of those that are new. And then I'm going to talk a little bit about Mesos as one example of how you can manage the distributed environment, for example. Oops, I can type. Okay. So first thing I'm going to do is just, and let me see if I can get this all moved up a little notch in case it's not easy to see. How many people can see past that? It looks like it's a bit low. You're getting okay there? All right, that should be good. So what I'm going to do first is just, okay, so let's take a look at the images I have on the machine. So I have a couple of things that I've downloaded, and then I've got this one that I want to delete, actually. So that was me not finishing my cleanup. So I'm going to show you how to delete an image. Isn't that awesome? So demo 1. Oops, wait, sorry. I think I'll do it this way. Hang on. Docker. I didn't say Docker, so. RY and demo 1. My tab isn't working. Okay. Let me see what's running. Docker PS tells me what Docker images are running. I think I left something still as a container here, so we're going to have to take a look at that. And that's where we are. Okay, so see that demo 1. So I need to get rid of that guy, and that one is called, yes, image demo 1, and the name is demo 1. Oh, there we go. Okay, so we're going to say remove demo 1. There we go. Okay. And we'll say got to get my name again. Okay, and I'm going to remove the image demo 1. Okay, so instead of showing you that after, I show it to you before. It's all good. Okay, so Docker images now is clean of that. And there we go. All right, so first things first, I have an application here, so I'm going to just show you that, app.js. And in that app, it's really just an Express app with Node, very simple, just for the sake of showing, a message. So Ola from Node on host. So instead of, I don't know, Ola, we'll type something else just to show that it's updated. Because Ola would be San Diego, right? Where are we? Crikey. Is that how you spell that? I don't know. Somebody said that to me this week. I thought it was fun. So there you go. Okay. Okay, so there's an edit on app.js. So this is just a simple Node app. Let me go to my Docker file. So, I build my app. I'm in Sublime. I'm in my favorite editor. I'm basically, doing development the usual way. But instead of, running it directly in Express or being on Windows VM and running it in IIS and so on, right? I can containerize it. So I create a Docker file and I say, look, my base image is going to be whatever operating environment I plan to deploy to. So this is Linux-based, right? So I'm going to choose a base image that's based on the same version of Ubuntu or whatever is my plan to deploy. In this case, I chose Node Slim. Node Slim just gave me a prepackaged version of Node, a lightweight version of Node that I could run this example on, which was also based on the same, Linux base image. So the idea is, like an onion, I'm layering on top so I can build these base images that I don't have to change or mutate, and then I can add my software to the end, right? So here what I'm doing is running NodeMon, running Express, getting those things installed, and then moving my source over. So we're basically copying the source over. And then we're exposing the internal port, so that's the internal image. When it runs as a container, there's an internal port, and then that'll be mapped to the dynamically created or fixed port that we choose when we run the container. So there's the concept of the internal port and then the external port that's on the VM. Now that's going to become important when we think about distributing those containers across your cluster. And because you're probably not going to want to fix the port, you're going to want that to be dynamic so that it can be load balanced, right? But we'll get to that. And then we're just going to say where the entry point of the app is, right? So this is going to be running like a Node app. And so we're going to save this. I don't think I even changed it. And that's my Docker file. So Docker build. And we'll say demo 1 dot. So we're basically going to build the image. And that's going to go ahead and fetch npm and add those things to the image and build this immutable image, which is the thing that I can run as a container. So now this immutable image is the thing that I could publish to a Docker Hub registry or wherever my registry is for my company, which is another important discussion. Where do I publish these things? So we'll come back to that. And then we've got the concept of, so right now I'm just going to run it locally. I'm not publishing yet. But when I do publish, that means that theoretically I could have a process that will pull that image and push it out to the VMs in the cloud, for example, for my dev, QA, acceptance and or staging and prod, right? So right now, just running locally, I should have this image. So we'll say Docker images. And here we go. I've got Docker demos, demo 1 again. So Docker run, we'll call this demo 1, and port 8080, map to 8080, and then demo 1 image, and go. So let's do this, Docker PS. Do we have it running? Yes. So that should mean that I can browse to that and go to 8080. So localhost and 8080. Oops. Nope. Did I do something wrong? Oh, sorry. That's my fault. Excuse me. It's not localhost because I'm running this in Kitematic and it's a VirtualBox. So, oops. Okay, so crikey, there you go. And we know it was the right one at least, right? Did I spell that right? I don't know. Yeah, okay. All right, so I don't think that constitutes a demo fail because it actually went. So there you go. All right, so that's just one example. So here I am, I'm in my development environment, I'm running, this is nice and clean. You see how fast that was though, right? I mean, not building of the app, because obviously I'd have to write some code. Can't do that for you. But if I go Docker PS, I can see that the container's running. I can say Docker stop, and that will be stopped. So if I go back over here and refresh, it's obviously going to be gone. Make an update, publish it again, Docker start, demo 1, and then super fast, and there you go. Now, of course, it's only got 3 lines of code, but still, it's always fast. It's pretty fast. There you go. So once I'm ready to publish, then I'm probably going to get some sort of process where I check in and it produces an image. So you can do that automatically with Docker Hub, for example. You can obviously use Jenkins and have a build step that actually does the Docker build for you from your repo. Link it up to Bitbucket, link it up to your GitHub, your Git repo, whatever that is. And then if you wanted, you could do full automation CI/CD, although I find that it seems in our latest projects together with our teams that do all that stuff, I'm not a CI/CD person. I just listen to what they advise. And it just seems like the control over that step seems more appropriate. We do the automatically build and get the image into the repo, but we don't necessarily want that automatically pushing out to prod or whatnot. We want to have some control, especially since you might be checking in a lot, and that means you would be building a lot as well, right? So just a thought. At the end of the day, what I was going to show you there, though, is that in my GitHub repo, you can do things like version your, let's see which one I want to show you, hang on. You can do things like when you check in or push, it will, you can tag it and have it version the deployments for you. So you can have V1 and have that tie to latest, and then check in V2 and make that the latest, and V3 make that the latest. So you can have the concept of which version do we want to pull. So you always have this immutable image still. And then maybe QA is always on the latest, but if you're using another secondary QA or UAT, maybe that one should be the one before because they're still stabilizing on that before it goes to production and gets promoted. So something like that. So I can also do things like check in to GitHub and have that automatically link. So for example, this guy, although here, let's go to CI, this is an automated build. So basically, if I check in a change to that particular one, it will automatically run a build. So let's see what happens here. I'm going to go into, let's see what directory I'm in. There we go. Hello, world, CI. Okay. So this is another Docker file, very similar, simple. If I wanted to make a change, and then let's say I make this is hello from San Diego, so now we're not in San Diego anymore. So we'll call this Sydney, and escape, save, and now we'll do a, git commit, new location. And then git push. And then while that's doing that, I can go over here and I can see if the build is running. I think I had an error last build, but that's okay. It should show that I'm going to start a build in about a second. You'll see that popping up here, one of these moments, and it'll queue, see, start the build. So then I'm going to have an image in this repository. And the images in the repository, like I said, can be versioned, can be tagged. And then eventually you'll pull the image you want and run it locally. So for example, I can go back to this repo here, and let's say I go to here and say Docker, well, let's see Docker PS, and Docker PS A. Okay, so I'm just going to take a look and see, ooh, I'm not scrolling the right place. There we go. Docker, demos, okay, good. So I don't have one yet for the hello world. So we're going to do a Docker run, hello world CI, P, 8080 or 81. And then we'll call that DOS blonde, hello world CI. And that's probably it. Wait, what did I miss? What did I miss? Oh, I forgot a space. Yep. Okay. So Docker PS, what do we have running? Hello World CI. If I don't have that locally, it would pull it from the repo and run it. So that would be the equivalent of what we end up doing when we push from Jenkins or something, right? Okay. So why did I go through all that? Because there are some things that are simple, and then there is the concept of I want to build this application. It's a solution with many services. I want to deploy that to a cluster out in my cloud, basically, right? Load balance cluster. And so I need the ability to potentially, and I'm going to use Azure Container Service as an example just because, but either way, the idea is I'm probably going to want to have an orchestration engine, which is clustered, and that's going to be responsible for scheduling deployments of all of the services, meaning that I have a mechanism whereby I can set up things like service discovery, set up load balancing across those services, have health and restarts on the services, so when a service is no longer responding, somebody's listening to that heartbeat, somebody's restarting the service, or somebody's replacing it and making sure there's another one running. So all of those things are the stuff of complexity. Those are the things you don't do when you're one guy, in a dev shop, deploying to a load balanced pair of machines. You need tools for that. Otherwise, you're building your own tools. Otherwise, you're picking from all of the open source tools which do exist out there and becoming an expert at one of them to figure out how you're going to manage this stuff. But UI helps, and tools help simplify a lot of these processes, and they've come a long way. A year ago when I was doing discussions about Docker, it would be that we didn't quite have networking baked, and now Docker, what is it, 1.2 now? Yeah, I always get the numbers wrong, but I guess the point being the latest release, right, now has all of that functional. We've got service discovery baked in. Swarm is working better than it did before. Now they have the Docker data center, which is the kind of proprietary version that is a paid version, a licensed version of all the tools in a package ready for you, including the registry where you would publish your actual images. And so that's where we get into things like, although I'm not showing it on this picture, somewhere over here is a registry, right? Somewhere over here is the place where our private images for our corporate organization get published and promoted between dev and QA and prod and so on. And so I probably don't want to put that in Docker Hub, open registry. I'm either going to pay for a private registry or I'm going to host it myself. And hosting it yourself is not trivial. You have to make sure that that's a first-class citizen, that it's got disaster recovery around it, and so on, right? So having that come in a package like Docker Data Center is helpful. Having that available to you in places like Amazon, where they have a service for that, is helpful. In Azure, we don't necessarily have that built in, but we do have things like Mesosphere, Data Center Operating System, or DCOS, which at least provide the tools around the orchestration with Swarm or Marathon, which is the one that I'm going to be using. And also the agent node management around that. So where you have these scale sets, which is the VM that has Docker Engine on it, and the agent that listens to Marathon, so that the heartbeats of your service are being sent somewhere, and so that something can monitor, manage, and listen to those health heartbeats and handle scaling. You ask for more services, send those across the nodes, right? So with that, again, just thinking about how you design more of a real system, putting another perspective, you're going to have on Azure, for example, and again, this would be different on Amazon and various deployments. Just as an example, you're going to have your load balancer coming in with requests, and you're going to want that to load balance across if you're using websites and putting those in containers, as well as your services behind the scenes in containers. And those can be distributed across, again, any number of nodes in your cluster, possibly multiple tiers. And then you want to have that load balancing dynamic discovery working. Make sense? So with that, an example of this, again, there are many tools for this. If you use the Docker DCOS with Marathon, then you're going to have a Marathon load balancer endpoint that you could have on each node in your agent cluster. And then that will keep track of the services across all the nodes, so that when a request comes in for service 1, it knows where all the service 1s live. And there could be 3 on one machine and 1 on another machine and several across many machines because of server density, which is where we get into when I schedule services and say I want 20 instances and I only have 5 machines. That means each machine potentially gets multiple instances just to help with managing requests and isolating those in those individual containers, right? Make sense? Okay. All right, so yes, so I guess to that, let's have a quick look. I'm going to go to here. And so what I have right now is I'm tunneled in, actually, to 8989 local, is to a Azure deployment of the Azure Container Service. So there's a template for this. I've got a template that's deployed right now, which is a single node for the management orchestration cluster. It's not a cluster, sorry, it's a management node. And then I've got 3 other nodes. And so what I'm going to do is just give you a quick example of what kinds of things I might do. I'm going to start with, Marathon Load Balancer. I'm going to install that package here. So we're going to install that package on the cluster. And what that's going to do is put the agent node on each of my 3 agents, which is my server nodes, right? And then it's going to install the Marathon management load balancer in the management node so that I can actually go and take a look. So it looks like this is done, I don't know, yeah, okay. So now I'm going to go to the dashboard. So this dashboard shows me actually how many nodes I have, I think. There's my 3 connected nodes to the cluster. Now it has these components which are related to the load balancer that I just installed. I don't have any tasks actively running right now. I don't have any failures right now. That's good. So it's giving me a bit of a dashboard, a bit of a visual around what's going on in the health of the cluster. Make sense? Okay. Now, with that, let's go over to this guy. And so this, and I'm going to just refresh this, is my Marathon interface. So let's get this reloaded. And oh, I'm so happy internet's working. That makes all the difference, doesn't it? What else would I do up here? Yeah. Although that might have been fun to watch for a second, but anyway. Okay. So I've got this Marathon load balancer right now, and I'm actually going to widen this up so we can see the full screen as much as possible. And yeah. Okay. So what I'm going to do is create an application. Now, I would automate this with Jenkins probably and push out the application that way. But you can describe in a JSON file what you're going to push and have that be scheduled. So what I'm going to do is go over here and grab this JSON file. And what it does is it describes a couple of important things. One is, okay, I'm going to deploy a web app called web. And then I'm using network bridge, which means that it's going to dynamically assign ports to every one of the instances I deploy. And that's really important because we obviously need it to be dynamic, and we want the Marathon load balancer to automatically know where all those instances live, and that's what's going to be provided for us. Port 10,000 is how the Marathon load balancer will look for this service. So basically, port 10,000 requests to Marathon load balancer know, okay, we're going to go and look for all the web instances, this app. So I've got to have 3 instances to start with. And I guess that's the main thing. And this is the host we're going to be hitting, which is my Azure host. Okay, so I could have different subdomains for different services. If I want to do something more complex like routing with /service 123, I have to add a little bit more logic. But we're going to just leave that alone for now because it's an hour. Okay, so I've got that copied to the clipboard. So let's get away from that for a sec and go to JSON mode, which means I can paste this guy in and say create application. And now you can see it's deploying, right? It's pretty fast. At some point, what we're going to see is all 3 instances are running. There you go. Okay. I should be able to hit that service. Let's see if I have a link handy over here. There. So here's the service. Now, eventually, if I keep refreshing, we're going to see this port change, right? This is the internal health requests coming from the internal server. So there's health pings to see if the service is alive at each instance. This is showing me, this is my web app, right? So as I hit it, it's showing me this information. So this is coming from inside the app. And at some point, when I keep refreshing, we should see that it changes from, 172.1703 to something else, because there's about 3 different, I don't know, it's just taking time, see, connecting. I know you're out there somewhere. While you're thinking, I'm going to come back over here. Okay, so you can see here I've got 10, this is the internal IPs that were dynamically allocated to the instances. So I've got 05, 05, 05, but these are the ports, the unique ports that were assigned. So if I kind of come in here and look at each port, I should see, oops, that's not what I meant to do, sorry. I meant to go here and see that that's 1702. And then if I go back here again and click on this one, this is 1703, you see, and so on, right? So each of these guys has their own separate IP, dynamically allocated. Now, while I'm doing this, I'm going to go ahead and scale this and add like 24 or maybe more. Let's go to, I don't know, 40. What the heck, right? So let's scale the application. So now what we're going to see is that it's, going to start adding, you see, staging, 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 all the tasks. If I come over here, we're going to see 10 staging. See, it's processing the tasks, getting it done. It's going to give me some errors if I ask for too many nodes, that more than it can handle resource-wise to deploy, things like that. So far, so good across my nodes. Failure rates, ooh, increasing, so we've got issues. It's going down, okay, right, that's exciting. I just want to stay here and watch that for a minute. Okay, so shiny things. Why is that not working? I'm not sure. I think it's just internet. I'm going to hand wave that, but it should be working because you saw it work the first time, right? Wonder why. I'm just going to let that refresh and think, come on, really? Come on, you could do it. Well, while it's thinking, what we do know is that it's staged a bunch of these guys and that maybe there are some errors. You can actually go in and look at the standard out and errors and so on. So it's pretty interesting, right? So it's still working on it. It's only got 11 of the 40 deployed. It's still thinking. But I guess the point that I'm really trying to make is that the scheduling distributed the nodes across more of these, across the whole cluster to where each of these nodes now has more services on them. So I've got 6 staged. Each node is going to show me what it's got available and what it's got scheduled. Well, this is the total scheduled, so that's not correct. But and then this is 1703, and you'll see that we probably hit the other ones here, so 1706. So you can get the idea of the distribution across all the nodes, right? And the most important part of that is that now with the Marathon Load Balancer built in like this, I can just hit the port 80 IP that you saw totally working, right? And it will figure out which node to hit, right? So that's really pretty sweet. And we didn't have that before. So I think that what the message I'm trying to give you is that the tools are evolving nicely to where if you spend some time with them, you can actually, manage this stuff and have all these multiple little services running around and build in some sort of health monitoring, recovery, when services are no longer working, have them replaced and so on, because the tools can do that. You just have to sort of spend some time with them and understand where to watch for the alerts and, where to set up your health monitoring endpoint, which is usually a default 200 response, that kind of thing, okay? Okay, so that's a quick look at the Docker side. Again, the point being, the simplicity is really elegant around just working with containers and pushing them out and having them, the images immutable and running them and they work everywhere. And the idea of the tooling helping me with the scale and distribution and load balancing really takes a load off. It just means make sure you're thinking about that, right? So let's talk then about ServiceFabric, because there's a couple other topics that we haven't hit on, which is maybe like the state management aspect. So if I have services and I've got this concept of each service should own a certain data model and state, and I want that state to scale, and the first thought I might have is, well, I certainly don't want to build, Redis and link that into my container structure, because then it's not clustered and it's not reliable. And I would need that Redis to be clustered and reliable and have a quorum when I write to it so that I know. And Redis is a bad idea. Maybe that's more of a caching type of model. So let's talk about MongoDB or Cassandra or something like that. The point being, I still need to think about the state, right? What is that ownership of state for each of these services that I'm putting in my microservice architecture? And I don't really get that for free in the Docker world, although I can build that. I can have a MongoDB cluster. I can decide to use collections as my vertical behind the services, and then I can figure out how I'm going to relate those things, whether I'm going to use event sourcing models for if I update an order, let's create a trigger that will also update the customer table and make a relation. Doing things like that can get complex, like event sourcing, or can be, super simple if it's just a relational transaction, and then there's somewhere in the middle there, right? It just depends on the model, it depends on the query patterns, and that's where the hard part comes in, typically. But let's talk about maybe ServiceFabric, because some of the tools that they provide actually build some of that in, which I think is neat. So we've got this other perspective on microservices and tooling that adds some value in a different way, but then flickers, because I don't know why, really. You will give it a good session rating. I don't know what that is. That's bizarre. Have I done something wrong? Friend at the back? Have I said something that offended the projector? Should I reconnect? Is there a reason for this?
Try to reconnect it.
I just did that. I'm going to try again. Okay, calm down, sister. Let's try again. I'm doing this slowly because maybe it will, oh, isn't that wonderful? Okay. Hold everything. Good thoughts, people, good thoughts. Are you kidding me? Okay, tell you what, we're not going to do the slideshow. We're just going to show the slides because that appears to be okay. So the animation will be pretend-like. So I don't know what that is. Okay, so Azure ServiceFabric. Again, you know, I'm focusing on this as a platform because it is the microservices sort of PaaS platform that Microsoft has pulled together. And it is pretty sweet in some other ways. So it's very different from the Docker experience because you're going to be Visual Studio, you're going to be in your familiar environment. As a potential topology, you know, I'm going to still maybe have my front-end web apps that I could deploy in PaaS and keep nice and simple, but they're going to call back maybe into a services tier. So one of the things I wanted to touch on is the idea that when you think microservices, it may only be the services layer that become the microservices that you want scaling and deploying in the middle tier and having those frequent lifecycle updates and feature additions, but the websites are still the way they are. And then maybe there's a back end that's still the way it is. So you're inserting yourself in the middle as a microservice layer. And that's a good way to consider migrating, for example. Take a few pieces that need to scale and that you want to compartmentalize and start pushing those into the microservices tier. So that might be one model, and I'm just illustrating that here as well, right? So I've got my cluster at the back, which is my virtual network with my Azure ServiceFabric cluster. And actually, I put here, this is web API and services, so I'm actually not really showing the front end on this. I just got confused on myself. So the front end here, what I mean by that is you need a way to get into the ServiceFabric cluster. The cluster actually, by default, if you create stateful services, actors, and so on, those actually are not accessible to outside the cluster unless you expose an HTTP endpoint, which would be like an OWIN-based service web API, if you will. And then I could put an API management gateway in front of this or just have a web app call it directly. So this is the whole cluster, is what I should have been saying. So the load balancer is coming into the cluster, and I'm opening up port 80 services that are just traditional web stateless services. And then I'm calling back into my stateless or stateful compute. So each service can be either a stateless thing that is scaled out across the naming service, which is not accessible to the outside world, outside of the cluster, or a stateful compute, which could be anything from it can be, you know, again, you can have guest executables, which are Java, which are other platforms. You can also have managed code, which is your traditional .NET application, you know, C# code, and so on. You've got the concept of stateless and stateful reliable services. The reliability aspect comes really with the state, which is I can have a service that has the concept of state, and then it will replicate that state across the nodes and make sure there's a quorum anytime I do a save, and make sure that if I can't save to the quorum, to complete a quorum, then it will reject the message. So we can guarantee that it's been saved and replicated before we get a return from the method, if you will. And I can have stateful services like reliable queues. So now I can potentially replace my other queuing mechanisms if I'm in this microservices space with just a reliable queue that I know will hold on to the message literally until it runs. And so it's durable, and it's replicated, and it's guaranteed, yeah? So we use that a lot. And then there's actors. So an actor model is interesting because you have your traditional sort of perspective on actors, which is IoT is a classic example, right? Each device is an actor. It holds a state. And then, you know, when it's hydrated, it's there in memory and accessible quickly and replicated across the cluster, so it's available to any requests. And then when it hasn't been used for a while, or there's too many requests in parallel, millions of things running around, it will flush the ones that are not so active, so that it can conserve, you know, compute, memory, and so on. But it still preserves the state. It's still preserved. Make sense? So all of that's handled for you. But actors also have another interesting value prop, and that is I can do things like workflows. I can create a workflow where I kick off a job from a queue, and the actor's job is to negotiate the process of completing a payment order or something like that. And it's going to send an email to the user and a notification and save something to our distributed store, maybe save something to our analytic backend so that we have not only the state in the cluster that is replicated and durable, but also a copy of state for queries on the back end, like ad hoc queries. So that's where we get into the idea that an actor doesn't have to just be typical actor model perspective. It can also be a workflow management tool. And then you can chain them. Start with pulling something off the queue, calling another actor, and the state is managed by the actor, so we always know where we are in the workflow. It's done, yeah? So it's really an interesting model. So when you do a new project in Visual Studio, you're just going to have a similar experience you usually do, but you'll start with a template that creates a ServiceFabric project. And you'll have this concept of, I have on my GitHub, I know you can't really see that right now. Wait, let me make it a bit bigger. In my GitHub repo, I have already posted a pretty comprehensive README, hang on, just trying to get back here, on this entity calculator app. And what that has is an example of this actor workflow model with reminders that do triggers and event sourcing. So it's pretty interesting, if I do say so myself. Okay. But the point is that the app owns the services. So if I, again, just trying to scroll down here without losing the page. Yeah, no. That's where a slide deck would be nice. Like, animations and such. Here, why don't we do this? That's what I meant to do. Okay. Sorry? Yeah. What can you fix? Oh. Is this all on film? Hey, how's it going? Don't worry about it. It's fine. I already scrolled it up. I'm sorry? Okay. I didn't hear what he just said. Okay. So, click what show? Okay, but I thought the slideshow was broken. Didn't we establish that? It won't be broken now? Are we fixed? What was the problem? Get that on film at least. My God. I mean, don't leave me hanging like this. Okay. All right, so basically the idea is that the app owns the services it deploys. So when I create a ServiceFabric application, I'm going to add services to it, like here's my queue, my reliable queue, and here's my actor and another actor, and here's my stateless service. But the problem you can already probably gather is, how is that a microservice? If I'm putting everything in one app, how is that, if I deploy all that together, how is that a microservice? It doesn't feel the same as Docker, right? When I'm in Docker, I have a thing. It's an image. I'm building an image, and I'm going to push that one little light thing up and over the wall, and it's going to work. And then I'm going to have to stitch that to another thing, and that's where the networking comes in, and the load balancing across containers, and so on. But, the point is not that you can't do that here. The point is that the way you go about it is different. I'm going to have this app, and it's going to be the whole thing while I'm building it by myself. But when I have a team across, countries and distributed partners, I'm going to have to build additional apps that just deploy the one or two services that go together all the time. And that becomes my unit of deployment, lifecycle, publishing, and update. And you can also, with apps, deploy one update to one of the pieces in the app, and it will only deploy that one thing, version that one thing, but therefore version the whole app, and even do rollbacks and such. So we'll talk about that. Now that I have a slide deck again, which is awesome, by the way, thanks for that. Here's an example of what I'm going to run right now is an app that has a web front end, goes through API management to hit the load balancer and hit my stateless web services. And it's going to place orders for like a concert, like ticket orders or something. We just did this for a hackathon, actually, so it's really kind of fun. And the back-end stateful services, we have a queue, and that queue is going to be the asynchronous process that we know is guaranteed, reliable, durable, queued message to figure out if after receiving that that credit card token because we never want to hold all that stuff in the back end. We only get the token that says, yes, your credit card can handle the processing. And then we queue that, and then we talk to the credit card ordering, and we see if we can process the order and if there's enough tickets for you. You know how sometimes you order something on Amazon, and then after they say, oh, sorry, we didn't have it in stock after all, and they give you the message, that kind of thing. So making it async so it can scale when there's a Lady Gaga concert in town and 1 million people go to order at once. We need to queue all those orders. We can't possibly hit them all at once. Make sense? So we're queuing it up in a stateful service, and then the actor picking up the queue when it can. And now each order is an actor. So there's like potentially millions of orders all at once processing as they can. And when they complete, it's durable, it's persisted, and we can always get back to that order. And so in order to have a queue, a queryable pattern on the back end, we store it in a DocDB. So we actually fire it off to an Azure queue and a function, which is another form of microservice in Azure, like a Lambda in Amazon, will pick up that queue and take that order and process, saving it to a store that we can query ad hoc. In the meantime, my actors are still available so that the person that just placed the order can be waiting on the web page and see success or something like that. So it doesn't get put to rest or retired until it's not active for a while, right? So until it's purged. So let's talk about that. Let's go into ServiceFabric. And I'm just going to start by showing what that looks like. So here is my application completed, right? So I'm not going to start a new app. Anybody can do that. You create a new app, you're going to get this ServiceFabric app, which we see here, and it's showing a list of my services in there. And so, my services are these guys, right? So I've got an actor, an order actor, I've got a service, which is my queue, and then I've got the web API front end that's picking up the requests. And so when I run this, what it's doing actually, if I take a look at the local cluster, let me just go there. My local cluster shows that I have an app already deployed and that it's available and running. And in my local cluster, if I were to, just to illustrate that I have a partition available and so on, let me do that. Honking horns, really, wow. Okay, so what I'm going to do is I'm going to take a look at, this is my actual API endpoint at localhost 8082. It's the entry point to the whole ServiceFabric cluster. And I have a place to place an order here. For example, I can go, not delete. How about we go to orders, and I can, post an order, for example, right? And so if I place an order here and try it out, then it's going to hit the API and run it. I can also do that, though, in my cluster that's in the cloud by just coming up to this website and placing an order. So if I go over to Web UI orders, and it's just thinking a little. You can always check the cluster, it looks good. There are no orders right now. I can go to the front, I can place an order, right? So order tickets now, and I can place one order, or I can do this thing, which is load test. So I'm going to go ahead and make a load test of 100 orders. So let's let that post. So what that's done is queued up to the function to do 100 orders, and it's going to go and iterate through that. And in the meantime, I have these partitions that I've created. So I have this queue, it's durable, and up front, because it's a stateful service, when I talk about state co-located with the service, I'm actually able to decide up front with a queue, how many partitions do I think I need? How many concurrent requests for orders when Lady Gaga comes to town do I think I'm going to need? Because you want to pick the highest number first. And then if I only have 3 nodes in my cluster, it'll distribute those partitions across the 3 nodes. But if I grow to 50 nodes or 100 nodes or 3,000 nodes, then it will distribute those partitions across all of the nodes. And it will track all of that for me. All I have to do is decide how many do I need. When we're thinking about data partitioning, it's a little bit different, because now you're going to think, all the customers that begin with the letter A, B, C through Z, those are my partitions. So I'm thinking about what is the finest grained thing that's reasonable for looking up partitions. So you think about that up front, but the rest is done for you because the state is managed, if that makes sense. So you can see if I refresh, if it hasn't finished processing, I should get a look at how many things are in the queue. It's still loading up here, so let's see. Or it might have finished, who knows. Let's see if I can do that again. And I'm going to run another one, because I think it might actually be done, because it's in Azure, so it's probably not so slow. I'm going to do one more, and then I'm going to go to load test. And it should show me, like I said, partitions with stuff in it. There we go, 3, 2, 2, 3. So it's distributing the requests across the partitions. You see that? So as the load's coming in, and it's doing that all for me, and it's persisting it. Make sense? So I think that's just one aspect to know about it. The other thing is that each individual order of this processing is its own unit. Every single ticket order is an actor, which means the partitioning is per order, which means it scales to the widest amount. There could be millions of those things running around, which is the purpose of actors. But the state is persisted, and I didn't have to think about it. All I had to do is decide what is the order ID or the thing that will be my partition number that is unique, which is my ticket order ID. Make sense? Okay, so what gets really interesting is when I go into Visual Studio and do things like, hey, let's make something fail and try to do a deployment or a rollback. So if I want to do an upgrade in place, let me see about this one. I'll just run one example of a contrived exception. Let's close this down for a sec. And what's happening is you can inform ServiceFabric of your health. So if you feel like something should be a service failure, which should trigger a rollback, or at least trigger UI notifications of failure, right? Then I can indicate, hey, we've not been able to contact the payment service for, like at least 3 tries. Let's report the error. Or I can't even run, my config is wrong. Let's report the error immediately. And so when I deploy this change that I just made, so let's go ahead and do a publish to the cluster. I'm going to go and publish, and I'm going to choose to do this locally for now, just because that'll probably be a bit faster. And I'm going to say, hey, I want to upgrade the application, which means I'm going to take the application as I have it, and I don't want to lose any state. I just want to upgrade in situ, which means it's going to roll in my update to the services, and if everything's healthy, instate the new services and retire the old ones without me having to do anything. And so if I go and configure the upgrade settings, it'll let me choose things like a monitored upgrade, and the failure action will be rollback. So there's that. And then lastly, I need to version the manifest. So what is my change, right? I'm changing the order service. So the new version is going to be 1.1, let's say. And that's going to now version the application, right? So okay, yeah. Okay. So I think that should do it. And then I'm going to try and do a publish. So this will do a publish locally, and if I look at my local cluster while it's publishing, we should be able to watch, this is my local, right? We should be able to watch the status upgrade in progress. You see that? And we should be able to watch, let's see if we can get to, oh, that's weird. I'm not seeing what I'm expecting. Oh, that's so strange. Okay, I'm not sure why that's happening. I must have deployed, you know what it is? I deployed it to the cloud. I didn't deploy it to local. So my upgrade is going to the wrong spot. It's not really upgrading. There you go. Let's try that again. I can fix this. I'm sorry? It's rebuilding right now? Sorry?
So in the output window, there's a failure of your deployment.
Yeah. Yeah, I think the failure, though, is related to what I just said. We'll see, yeah. Your cluster. Ooh, yeah, okay. I'm going to choose the right cluster, angles. And we're going to do an upgrade. And we're going to just check that I've got the right versions. So I'm going to version this. Service package. Okay. we're at time, so I'm going to just give this a shot. And what I should see then in my cluster up here is if the upgrade's in progress. I don't know why it showed upgrade in progress, or maybe I was just getting confused because it said 0, and that should have been a tickler that wasn't doing it. Let's see. So it's still building probably. It won't show up here until it's finished building. So while that's building, I'm going to let that go for a sec, and then let's just sort of, again, wrap up the discussion. So a couple things. Hey, I've got screenshots for things that maybe you didn't see yet. So for example, upgrade in progress. That happened. Okay. So the target version will show what it's going to move to, and then it'll show you how it's getting through the upgrade domains across the nodes while it's happening. And when it's done, it should show you the new version, which means it was successful, yeah? When it fails, it will show you exceptions, and it will actually, while it's upgrading, eventually show rollback in progress. And so it actually won't deploy the new services. So that's a really helpful, interesting thing. So it's interesting when you compare the platforms, right? This picture is really just showing what I suggested before, which is the thing that I have on my GitHub, which is a hierarchical set of actors, to where when I create a new sales order in New York, it actually updates the totals for USA and then Americas and then global with reminders, which are durable, that remind themselves when the actor's finished saving its state to go tell its parent to save, and so on and so on. And so it's creating this chain of actors saving updated state to where eventually I actually have a correct total across all the way up to global of all of the sales orders across the organization. So that event sourcing model is actually kind of a thing you can build into ServiceFabric really easily. And I think that's pretty neat because that's a very complicated model to build. So that's something to look at. You can read my blog about that. And then I think I've already covered this, so let's keep moving on there. We've talked about the density and scale. We've talked about partitions, so there's just a visual around that. So I guess it comes down to this. So when you think about choosing a platform, you know, we've talked about how you break down your services, that you might want to consider state and ownership of state. And then you might want to consider, how do I relate the state and how do I do aggregate ad hoc queries? So, and then there's the side of it, which is the managing of the networking and the clustering and the density of services across the nodes. But I've now showed you two platforms that actually can handle the density and distribution and automatic port mapping and load balancing of the actual services, which is kind of cool, right? I would say. And then, you know, the whole idea of registry and discovery is related to that. When I deploy another service, it registers with the discovery system so that when somebody wants to call it, you know, the load balanced environment knows how to find, you know, instances of the service across all of your nodes, right? Self-healing, another thing, the rollback that I just showed you, for example, and being able to detect when a service is not working, so having those pings in place, both of those environments do that. So it's just a matter of leveraging the tools available to you instead of going raw Docker, for example. You can do similar things with Docker Data Center, although that doesn't have all of the UI built in. You can do similar things with Amazon EC2 container services, but again, doesn't have the whole UI built in. So one of the choices that we've recently gone through is that, you know, the DCOS doesn't have to be on Azure container services, but in general, that platform has, you know, with Marathon, the tooling and the visuals around managing the ecosystem and the discovery and the load balancing and the health. And so that's nice. And then with ServiceFabric, you get a little bit of the same with a different development experience. And the state management side of it is really sweet on the ServiceFabric side. So, you know, finding the right fit for you is probably going to be, obviously, what platform are you sort of having an affinity to naturally? What do you know already, Linux, Windows, et cetera? What's more comfortable? Timeline, cost, time to market, and whether or not you have time to learn that new ecosystem or environment. Or you can think about things like migrating slowly, right? So one thing we know is microservices are part of your future. Our future. She's creepy. I just think it's funny. So we can take a quick look and see if that worked, although that could be a good or bad thing to end the show for. Let's see what we got over here. I'm taking a risk. We'll see if it upgraded. I don't know. Well, you saw the picture, right? So there. Okay. thanks for coming out for an hour and a bit more. I hope that was enjoyable to you, and even with the comic relief in the middle. So have a great day. That's a question. Thank you. Okay.